New Essential Mathematics, Year 11 courses, written by Terry Lee. Terry Lee is a former HSC senior marker who is currently retired. He has recently published his new Essential Mathematics Year 11 textbook. On his website, the free resources contain Extension 1 and Extension 2 HSC Mathematics Paper Solutions from 2006 to 2022. Mr. Lee said, "Many people pay money to buy HSC Extension 1 and Extension 2 Mathematics Paper Solutions. They are free on my website, and the working out is shorter compared with other editions. I already included the website in the description box below the video for your reference." Index laws that are covered in Example 1.2. Here are the index laws that are applied in the example on the right. The index law on multiplication. When multiplying terms with the same base, add the powers. A to the power of m multiplying a to the power of n equals a to the power of m plus n. The index law for division. When dividing terms with the same base, subtract the powers. A to the power of m over a to the power of n equals a to the power of m minus n. The index law for power of a power. When raising a term in index form to a power, retain the base and multiply the indices. Bracket a to the power of m bracket to the power of n equals a to the power of m multiplying n. Negative indices. A raised to the power of negative m is equal to the reciprocal of a raised to the power of m, bracket, a is not equal to 0, bracket. A to the power of negative m equals 1 over a to the power of m, and a to the power of m equals 1 over a to the power of negative m. Index law extended. When multiplying two or more numbers or pernumerals raised to the power of m, raise each number in the brackets to the power of m. Bracket a multiplying b bracket to the power of m equals bracket ab bracket to the power of m equals a to the power of m b to the power of m. When you are applying index laws, there are 2 points you need to pay attention to. Firstly, you get a chance to know your numbers. To know your numbers, especially your times table, is super important here. For example, 6 equals to 2 multiplying 3. 9 equals to 3 squared. 8 equals to 2 cubed. 4 equals to 2 squared. Secondly, you need to connect your questions with the specific index laws to apply them. Example 1.2. B. 3 to the power 4 multiplying 6 to the power of negative 3 over 9. To start this question, we first look at 6 to the power of negative 3. According to the negative indices law, a raised to the power of negative m is equal to the reciprocal of a raised to the power of m. So we can rewrite 6 to the power of negative 3 as 1 over 6 to the power of 3. That's the first step. Now we are looking at the 9 in the denominator. Because 9 is a 3 squared, so we can rewrite it as 3 squared. That's the second step. Considering your times table, 6 equals 2 times 3. So in the third step, we can rewrite 6 as bracket 2 times 3. So 6 cubed becomes bracket 2 times 3, bracket cube. According to the extended index law, when multiplying 2 or more numbers or pronumeraries raised to the power of m, raise each number in the brackets to the power of m. So we can rewrite bracket 2 times 3 bracket cube as 2 cubed times 3 cubed. That comes to the fourth step. When we look at the fourth step, 3 to the power of 4 over 3 to the power of 2, multiplying 2 cubed, multiplying 3 cubed. In the numerator, we have 3 to the power of 4. In the denominator, we have 3 squared multiplying 3 cubed, which gives 3 to the power of 5 according to the index law for multiplication. Now we can cancel the common factor of 3 to the power of 4 from numerator and denominator. Therefore, we get 1 on the numerator and we get a 3 on the denominator. Therefore, when it comes to step 5, the question reached the result of 1 over 3 multiplying 2 cubed. Because 2 cubed equals 8, 3 times 8, according to the times table, is 24. Therefore, we get the final result of 1 over 24 to question B. A. 3 to the power of negative 2 over 6 to the power of negative 3. To start this question, we first need to use the negative index law. A raised to the power of negative m is equal to the reciprocal of a raised to the power of m. To look at the numerator, 3 to the power of negative 2, it can be rewritten as 1 over 3 to the power of 2. 6 to the power of negative 3 can also be rewritten as 1 over 6 to the power of 3 at the same time. So we reach the first step. The original question now becomes 1 over 3 squared over 1 over 6 cubed. To simplify this complex fraction by multiplying 1 over 3 squared to 6 cubed over 1, we get the second step, 6 cubed over 3 squared. Again, according to your times table, 6 could be rewritten as bracket 2 times 3. So 6 cubed on the numerator can be rewritten as bracket 2 times 3 bracket cube. And on the denominator, we just copy 3 squared. That's the third step. According to the extended index law, when multiplying 2 or more numbers or pernumerals raised to the power of m, raise each number in the bracket to the power of m. So we can rewrite that bracket 2 times 3 bracket cube as 2 cubed multiplying 3 cubed. That's the fourth step. And we can still copy the denominator 3 squared. Now we are looking at the 3 powers on the numerator and denominator. On the numerator, we have 3 cubed. On the denominator, we have 3 squared. By canceling the common factor of 3 squared, we get 3 on the numerator. And on the denominator, we get 1. That comes to the fifth step. The result is 2 cubed multiplying 3 over 1. And this 1 could be omitted. So we get to 2 cubed times 3. Because 2 cubed equals 8. And 8 times 3 will give you 24. So 24 is the final result of A. Now let's look at D. Bracket 2 to the power of n bracket square over 4 to the power of n square. To start this question, we could use the index law for power of a power in the middle on the left. When raising a term in index form to a power, retain the base and multiply the indices. Bracket a to the power of m bracket to the power of n equals a to the power of m multiplying n. So the original question of D in the numerator, bracket 2 to the power of n bracket square, can be rewritten as 2 to the power of 2n, according to this law. Because 2 to the power of 2 can give you 4, so we can do the second step to write 2 to the power of 2n as 4 to the power of n. Now it's good, because we can start to use the index law for division. The numerator and denominator have the same power of 4. Have the same base of 4. So we keep the base 4. We subtract the powers as n minus n squared. The final result for D is 4 to the power of n minus n squared. That is the end of example 1.2. Welcome to my channel. Let's study Terry Lee's Year 11 Mathematics textbook together. See you next time. Bye.